We're given f of x comma y, and we're asked to find the following second order partial derivatives. But before we find the second order partial derivatives, we need to find the first order partial derivatives. So we'll begin by determining the partial derivative of f with respect to x. So we'll differentiate f with respect to x, treating y as a constant. So the derivative of 5x to the 6th with respect to x would be 30x to the 5th plus the derivative of 4x y to the 3rd with respect to x would just be 4y to the 3rd. Again, the derivative of 4x would be 4, and we're treating y to the 3rd as a constant. And then plus the derivative of 6y to the 2nd with respect to x would be 0, again because we're treating y as a constant. And now we'll find the first partial derivative of f with respect to y. So we'll differentiate with respect to y, treating x as a constant. So the derivative of 5x to the 6th with respect to y would be 0. The derivative of 4x y to the 3rd with respect to y, we'd multiply by 3, subtract 1 from the exponent, that would be 12xy squared. And then the derivative of 6y squared with respect to y would be 12y. And now we want to find the second order partial derivative with respect to x, which means we want to differentiate f with respect to x twice, treating y as a constant both times. Which means now we'll find the partial derivative of this partial derivative with respect to x again. So the derivative of 30x to the 5th with respect to x would be 150x to the 4th. And the derivative of 4y to the 3rd with respect to x would be 0. Next, we have the second order partial derivative with respect to y. So we want to differentiate f with respect to y twice, treating x as a constant both times. Which means now we'll differentiate this partial derivative with respect to y again. So the derivative of 12xy to the 2nd with respect to y, we would multiply by 2 and subtract 1 from the exponent, giving us 24xy. And then the derivative of 12y with respect to y would be just 12. And now these next two partial derivatives are called mixed partials. For this first mixed partial, we want to differentiate f with respect to x first, and then y, which means we'll find the derivative of this partial derivative with respect to y. So the derivative of 30x to the 5th with respect to y would be 0, and then the derivative of 4y to the 3rd with respect to y would be 12y squared. For the next mixed partial derivative, we would differentiate f with respect to y first, and then x, which means we'll find the partial derivative of this partial derivative now with respect to x. So the derivative of 12x y to the 2nd with respect to x would be 12y squared. And the derivative of 12y with respect to x would be 0. And notice how these two mixed partial derivatives are equal, and this will be true as long as f and the first partial and second partial derivatives are continuous. Before we go, let's talk about the meaning of these second order partial derivatives. The sign of the second order partial derivative with respect to x indicates the concavity of f of x comma y in the x direction. If it's positive, it's concave up in the x direction, and if it's negative, it's concave down in the x direction. And the sign of the second partial with respect to y indicates a concavity in the y direction. So again, if the sign of this is positive, f would be concave up in the y direction, and if it's negative, it would be concave down in the y direction. And the mixed partial derivatives tell us how a partial derivative in one variable is changing in the direction of the other. We can also say that the mixed partial derivative with respect to x and then y tells us how the rate of change of f in the x direction is changing as we move in the y direction. I hope you found this helpful.